I'm going to show you how to complete lab number 9. Right now, I'm sharing lab number 9 document. So let me see. It starts from here. The purpose is given here. Please read the purpose. There is some introduction here. There's a please read all this, and then the procedure starts from here. So I'm going to go through the procedure with you. So we have 3 tables. For each table, I'm going to complete 1 row for you, so you can see how to complete your lab. So number 1, for part 1 of your lab, where we are looking at the dependence on amplitude, you need to go to this link. So you click on this link. So once you click on this link, you're going to see a simulation. So let's go to that link. So what I'll do here, I'll stop sharing, and basically I'll just share my screen so I can move back and forth. So right now I can share the simulation here, and I'll be following the instructions with you. Okay, so here is the simulation. Let me move this one a little bit, maybe at the corner here. This will be fine. Okay, so let's follow the instructions one by one. So we have opened the simulation. Number 2, add a little friction. So let's add a little friction, because in reality there is some friction. So you add a little friction, maybe like here. Instruction number 2, set the string to 1 meter long, and then pull the bulb 5 degrees away from the equilibrium. So 1 meter long. So let's go to the simulation. This is 0.70. 1 meter is here, and then we have to set it swinging like 1 degrees. So I can do that like 5 degrees. So we can either way, maybe 5 degrees is somewhere here. Then watch it swing. Okay, see, swinging like that. That's a pendulum. So we have set the length to 1 meter, and it's swinging. Okay, so now let's see what's the next on the list of instructions. Measure the time for 10 oscillations. So we need to measure the time for 10 oscillations. Now we are going to go to the simulation. There's a stopwatch here. Click on the stopwatch here. So I'm going to count when the bulb is at the maximum displacement, maybe at 5 degrees. Let me see. 5 is here, so I pause it. So I have to start the watch, and then I have to start my simulation, and then I'll count for like 10 oscillations. A complete oscillation is the mass going to and then back. That's 1. If it goes to back, that's 2. 2 back. So I'll be counting like that. So let's start both the simulation and start the stopwatch. So that's tricky, but we can do it. So I start the watch, and then I start the simulation. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So stop there. So I paused the watch. So it is always important to pause the stopwatch first, because that's the one that you are actually reading your time. So I got this is 20.45 seconds. 20.45 seconds. So let's see what's on the next of instructions. Instructions tells us that to find the period, divide this time by 10. So period is time for one complete oscillation. So we are going to divide by 10. So we divide by 10, then we get our period. Okay. All right. So we're going to say, okay, at 5 degrees, the period is 2.045. Remember, if you go to the simulation, our time was 20.45 seconds. If you divide by 10, it will be 2.045 if you divide by 10. Okay, so that's it. And then you can do the same for 10, 15, 20, 25. Now let's move on to part 2. You go to the simulation again. Make sure to press the reset button. So let's reset. So the reset button is right here. Okay. And next on the instruction, add a little friction. So add a little friction. I'm going to add a little friction like that. Next on the instruction says that now vary the mass and measure the period and record the data, keeping the length of the string the same. Okay, also make sure to use the same amplitude throughout. Okay. All right, so we can keep the length constant. So let's choose 1 meter and then do the experiment again. So I'm gonna choose 1 meter. It's up to you. The length can be held constant. It's up to you to keep it 0.7 or you can keep it 1 meter. It's up to you, as long as it is constant. Then what are they saying? So they're saying that we need to change the mass. So so we'll be changing the mass 0.20, 0.30, 0.45. Let me show you how to change the mass. So you can change the mass here. Here you can change the mass here, but I have to keep it the length constant and amplitude the same. So I'm gonna use 10 degrees. So 10, each time I'll be starting from 10 degrees. 10 is here, 10 is there. Yep. So the only thing I'm changing in this part 2 of the experiment is the mass of the bulb, the mass of the pendulum, but the length stays at 1 meter, as well as the amplitude stays at 10 degrees. Okay, so you can do the same. Let's take our stopwatch, and we are starting from the mass of 0.20, 0.20, so 0.20. Okay, here. Okay, there. Then let's start the watch and then start this at the same time. So be fast. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Stop the watch. Okay, so I'll start with the watch. So I got 20.84. So I'll go to my table and enter here 2.084 seconds. Remember, we divide by 10. I got 20.84 seconds for 10 oscillations. For one oscillation, I divide by 10, I get 2.084. You can now change the mass. to a different one. I think we're changing it to 0.30. So change the mass to 0.30 and do the experiment again. All right, so you're going to reset your timer and do the experiment again. Start from 10 here and say, okay, let me do it again. Make sure amplitude is the same, length is the same. You only change the mass to 0.0. So you can do it again and then complete your data table. So you go ahead here all the way until you finish. We move on to part 3. It's fun actually if you know what you're doing. It's actually interesting. Part 3, I'm going to enter data for this part. So what are we doing in part 3? So make sure you press the reset button. So let's go back here. The reset, sorry, make it smaller. The reset button is right here. Press reset. Then what next? Add a little friction. So we add a little friction. So add a little friction. And what next? Choose one bulb, same mass. So that means we have to make the mass the same. So I'm going to make mass 1 kilogram. So the mass will be 1 kilogram, no change. And we are also fixing what? And keep amplitude the same for each trial. So we keep amplitude the same. So I'm gonna use 10 degrees as my amplitude, 10 degrees. So I can displace it like 10 here. Oh, I have to pause it. So 10 is right there. Then I have to start from 30 centimeters. So, and then I collect my data. So from 30 centimeters. So let's make the length 30 centimeters, which is 0.3 meters. Yeah. So 30 centimeters is like 0.3 meters. So everything is set. I have added a little friction. I have, I'm using the same mass 1 kilogram, and the angle here is 10 degrees. I'll be changing the length. Everything else is constant. Everything will be the same. I'll be changing length. So let's take our stopwatch. Our stopwatch is here. Then I'm gonna start, press the time, and press this almost at the same time. So 1, 2, 3, go. Press this and press that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. All right, so I got 11.07. So you go to your data and record that. So it's 11.07. If you divide by 10, it's 1.107. Okay, so remember, we are looking for the period. This is the time for 10 swings, 10 full swings. If you want the time taken for one swing, you divide by 10. Then you go ahead and vary the length to 40. So you go to your simulation. Everything is constant, so put it at 10. Mass is the same friction, but we have to make this one. What was it? Forgot the number. 40 centimeters. So let's make it 40. 40 is just 0.4. Yeah. Then you reset that and do the experiment again. So I'll do this with you. Second one. Let's do it. 1, 2, 3, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Stop that. So as you can see, we have 12.85. So you're gonna record that right here. So 12.85, that'll be 1.285. Remember to divide by 10. Let's check again. What did we get? We got 12.85. If you divide by 10, it'll be 1.285. 1.25. Okay. All right. So that's how you collect the data. To find the T theory here, you're going to use this formula. So this formula. So in the theory, T equal to 2 pi square root of L over G. Your L has to be in meters. G is 9.8 meters per second. So use your calculator to find out T theory for the last part. We can make these ones meters actually. Let me see. No, that's fine. Okay, but I think some of you will be confused. So let's make it meters. That's how the simulation has it. I think it has. Yep. So to avoid confusing others, let's just put this in meters. Oh, these are in meters, so you don't have to worry about converting. Okay, so that will be 0. All right. Okay, 1 meter, 1.0 meter. So what did I do? Oh, so that one must be 1.0. All right, so you have the length in meters, and you go ahead and find your T theory. Percentage error is just T. Let me share my screen for that maybe. Percentage error, or maybe I can write it somewhere here. Where can I write it? Yeah, here maybe. So I'm gonna share percentage error here. So percentage error is equal to T theory minus T experiment divided by T theory. You multiply by 100. All right, so there is absolute difference here, so it has to be positive. Whatever you get, it has to be positive. T theory minus T experiment divided by T theory, they multiply by 100. That would be the percentage error. All right. Okay, so that's it, and then let's look at some few questions. What else are you going to do after finishing your experiment? What's going on? Okay. All right, I hope you kept the formula. You just have to. Okay. All right, so that's it. Your job here is to complete the lab. I think we have some graphs to be drawn. Let's see. I think we have some graphs that we are expected to draw. Okay, yeah. Oh, I jumped over everywhere. Okay, it moved around. Anyway, but if we try to, okay. Okay, let's forget about this. Oh, I think it's still drawing. Okay. Yep, now better. Okay. So remember the formula. You can just play the video back. You can create the formula back. Okay. I'll just delete this because they'll be jumping all over as you open the document. They might be confusing. Let's just take them out. All right, so the discussion questions here, you can discuss on Blackboard. And then for under each one, under each part, you're expected to analyze your data. I have given you instructions here to plot your graphs. I want you to use graph papers, or you can use Excel to plot your graphs. Here are the instructions to plot the graphs. If you want, you can follow my instructions, or you do whatever you can to plot a graph. Make sure you label your axis, the y-axis and the x-axis, and title your graph. Okay, make sure you have a title and you have labels for your graph. So you're going to plot a graph for part 1. Part 2, looks like you're not plotting a graph. Part 3, yeah, part 3, you are actually plotting a graph. Yeah, you're plotting a graph for part 2 as well, under data analysis. Yep, so there's a graph for part 2. And part 3, there is also a graph. After you have everything, you're going to also plot a graph. So plot a graph. This one is a graph of period versus length. So each graph will have a period on the x-axis and the variable, independent variable on the x-axis. Like this one, on the y-axis there will be period, on the x-axis there will be length. And the second one, your period will be your period will be on the y-axis and your mass will be on the x-axis. The first one, your period will be on the y-axis as usual, but on the x-axis you have the amplitude. Okay, so that's how you complete the lab. You have 3 tables and 3 graphs. That means you need 3 paragraphs in the discussion, 3 paragraphs in the procedure, 3 paragraphs in the theory. So everything goes like 3 paragraphs, 3 paragraphs, like that. Okay, so just want to remind you not to copy these word by word. You need to rephrase, put it in your own words. Okay, there is a video of a pendulum here if you want to see a real pendulum. Just a string and a mass tied, then swings back and forth. All right, I'll stop here. If you have any questions, please reach out to me. Thank you so much.